This video is about why work matters in physics. So I've got some objects here on a table, and there's nothing special about these objects. I've got a toolbox full of tools here. I've got a hammer, I've got a nail, and I've got a jack-in-the-box toy. So as of now, they're all at rest. Nothing's happening to these objects. There's nothing special about them. But I want to show you that by doing some work on these objects in particular ways, I can change some property about these objects. Okay, so let's start with the toolbox. All right, like I said, it's full of tools, very heavy. And I've also got behind the toolbox here a can. I'm going to place the can right here. And I'm going to do some work on this toolbox by lifting it against gravity. It takes work to do this because I'm applying a force, and if the toolbox moves, I am changing its distance. And so I've done a force and a distance to lift the toolbox up. And by lifting the toolbox up, even though it's at rest, I have changed something about the toolbox. I have given it the ability to do its own work. And I can prove that to you by dropping it. And this toolbox now has its own ability to do work on the can and crush the can. There you have it. So the toolbox gained an ability to do its own work. When I do work on it, I give it the ability to do work on something else. Let's look at a hammer, for example. Whenever I swing a hammer, I apply a force and the hammer moves some distance. So I'm doing work on the hammer, but by doing work on the hammer, I then give the hammer the ability to do work on a nail. As an example, I've got a wooden board up here. I'm going to swing the hammer, doing work on the nail, pushing it into the board, and now I can hang something on that nail. So by doing a little bit of work on the hammer then acquires the ability to do work on the nail. My last example here is a jack-in-the-box toy. And this has a crank over here on the side. And this crank, when you crank it, oh, is it working? Oh, there we go. So when you crank the jack-in-the-box, you are doing work. It may not feel like you're doing much work because there's not a lot of force happening. It's a small amount of force, but you're doing it over a large distance, and in the distance that you crank your hand around in circles. So you're doing some work and you're putting in some work into the jack-in-the-box. By doing this work, I have now put something into the jack-in-the-box. It now has the ability to do its own work in lifting out a puppet. So I have put some work into it, and now it has the ability to do its own work. So if I were to set this back down on the table, the jack-in-the-box now has a different state than it did before. It's wound up. It's ready to go. It's ready to release the work that I put into it and do its own work. And so I have changed something about this jack-in-the-box by doing work on it. And I can prove that to you by just doing a tiny bit more work. Oh, gets me every time. That's nice. Okay. So in each example, the object gains a new ability that it did not have before. It gains the ability to do its own work. And this idea of something possessing the ability to do work is a really important concept in physics. Have you guessed what it is yet? If an object possesses the ability to do work, we say that that object has energy. So in each of these examples, by doing work on an object, by lifting the toolbox, by swinging the hammer, or by cranking the jack-in-the-box, I give these objects energy. So now we start to see why work matters. Doing work on an object adds or removes energy in the object in proportion to how much work is done. The more work you do, the more energy you add or remove. And energy is defined as the ability to do work. If an object has energy, it can do its own work on something else or itself. If you give an object energy, it can then move on and do energy and do work on other things. So Because there are so many different ways that objects can do work, work is defined as just applying a force over a distance. Because there are so many ways you can do work, there are so many different forms of energy. The big two categories of energy are kinetic energy and potential energy. Kinetic energy is things that are moving already. Potential energy is energy that's stored back and held in readiness, ready to be unleashed or released. And you can further divide these two big categories into smaller subcategories. Things that are moving have energy, sound waves have energy. Heat and thermal energy is a way that you can do work on objects. Things that are up high have gravitational energy. Electricity possesses some potential energy. Elastic potential energy, things that are wound up tight in springs or rubber bands or things like that that can release that energy. And even chemical energy is the type of potential energy that's stored up in food or gasoline or anything that has the ability to do work. That's chemical energy there. So you can start to see why energy is such a powerful concept in physics. And that's why I compare it to a power drill, because energy explains so much about the world we see around us, and it explains it in a way that we can actually measure. Energy is something that is measurable. So, what is energy? Well, like I said, it's something that's measurable. Just like velocity and momentum, energy is a measurement that we can make about an object. So in some ways, it's not very different from other concepts that you may have learned about already in physics. But unlike velocity and momentum, energy is an enduring quantity. An object's energy may go up or down, but this lost energy or this gained energy can always be traced to something else. Energy cannot be observed directly, so we can't actually see it or observe it directly, but nature seems to be keeping track of it because energy never appears or disappears. And this last little line here is the summary of a law that you may have heard of before, the conservation of energy, which says that energy just never goes away and never disappears, and it never just pops into existence. It always has some starting point and ending point. Another way to say that is energy is never created or destroyed. But that's all I've got for you in this video. Remember, habit is the battleground of character. All right, how many homework assignments should I give this week? All right, what I get? Oh, 666, 18 plus 7. Oh, 25.